Hello and welcome to the talk about how to do test automation without assertions. First, I want to tell you why I give this talk. So my goal today is that if you like what you see, you go to GitHub and you give us a star. Like, that's our currency right now. And for those who do, I even have stickers. So I'm going to bribe you, even if you don't like it. So, assertions. The problem with assertions is that you specify something very specifically. Like, imagine how would you test an umbrella? You would say, okay, it has to open, right? So you specify that you expect the umbrella to open, and if you do, the test passes. However, that's not exactly what the user experience should be like, right? And this is what I'm going to talk about. And actually, I'm giving you a demo on this. So I can make this even bigger. So this is a typical Selenium test, and all it does is let it run. All it does is it opens a login page, it enters username and password, it clicks on sign in, and as a typical test does, it just checks afterwards that the login was successful, so that the message success is displayed. Anybody ever had a Selenium test similar to this one? Okay, quite a couple. Cool. Now the problem is this is the underlying HTML. I can make that even bigger. And if I now say change the CSS, I remove one character. And now the website, from a user's perspective, the website is broken, right? This is not the website I want to use. However, because it's still success displayed, the test says, all fine, you're good. That's not what I want. However, if I change the ID or I remove it completely, this is what the test uses to identify the elements it wants to interact with. And from the user's perspective, doesn't matter. The ID is invisible for the user, but the test breaks, right? This is not what I want. This is exactly the opposite of what I want. It ignores important changes and breaks on irrelevant ones. Okay, let me see if we can do better. So this one is essentially the same test, except that it's now wrapping the driver in a Recheck driver. And this is the open source project that we want the GitHub stars on. Now let me again break the CSS and execute that. So as you see, the website is broken. The test executes just fine. But this time, the test says, oh, look, there's something different. So we got 116 differences. Maybe you should take a look at that and see whether you're cool with that. And now do the other thing and change the ID or remove it completely. And again, it's the same test. So we use the ID to identify the elements we want to interact with. And it would work the same for text or XPath or name or anything. As you can see, the test still executes fine and passes. And right, where it looks, okay. Now this is actually not a trick, that's how it works. I'm going to explain how we do that. So I hope now I got your full attention. So the idea essentially that we do one thing different. Instead of defining what we want to see in terms of an assertion statement, we approve it. So we say, okay, this is what I expect, I see it, this is fine. Now make sure it doesn't change anymore. Because what we think is that an automated test actually is not a test. Like, you don't code an automated test and see, okay, let's see what bugs it's going to find, right? You don't, if there's problems within the software, your automated tests usually don't reveal them. What you create the automated test for, though, is that if something changes and your functionality has a regression, so you break something, then the automated test should tell you. So essentially, it guards against introducing new defects. It doesn't find defects that are already there. It guards against unintended side effects. And with that, it's kind of controlling or guarding against unwanted changes, which means that it's more like a version control system than a test. However, compared to a version control system, it's not well equipped. So let's see to that. A typical version control system, like Git, tells you whether code has changed. However, it turns out that the code is not the software, because the code is just like the baseline, the fundamentals of the software. But on top of that, you get data, you get the configuration, you get a runtime system. So this is the user experience, right? It stems from the code, all right, but it's not, the code is not fully defining the software that's been executed. So there's a gap, something's missing in between. And that's because what we really want to know when we use version control system is where has the software changed. And for that gap, we use automated tests. If you think like that, then an automated test is a means to turn the dynamic behavior of the software into a static artifact that now can be governed by a version control system. This is the reason why you have to execute both the software and the test to close that gap. Okay. So now, for a second, assume that automated tests really are version control. Then we have, like this is existing, we already have approaches that can do that can fill the gap, that can treat tests like they were version control. And one example I want to give here is, it's again a unit test, so you give it some XML, then you have a remove element transformer that does something. You can guess what, it removes some of the elements, does the transformation, and then afterwards with an assertion you check the result, right? And essentially what it does is if you give it that XML at the top, and then it expects to receive that XML at the bottom. And what you saw is that it has an assert statement where it says the result should still contain the remove, should still contain the keep tag, but should have gotten rid of the remove tag. So again, this is what we want to see, right? The remove tag is removed and the keep tag is still there. However, the problem with that, again, is if you produce output like that, and it's not even valid XML, the test passes. Because, you know, the keep tag is still there and the remove tag is gone. So this kind of fulfills the assertion. Whereas this is what you want to see. And to address this problem, there's golden master testing, snapshot-based testing, characterization testing. There's different names to that. Baseline testing, difference testing, but it essentially all means the same. That we create a copy of the output that we want to see and compare the actual output to the copy of the output that we created. So for this example, for the XML example, there's an existing library that's called approval tests. And this works essentially that you just put in a line where you say verify XML. Then, as I said, it will create a copy. The first time you execute that, it will create a copy of the XML and fail because it doesn't know what to compare to. And the next time, it will make sure that there's not a single character changed compared to that copy, which means that it only passes if the output looks like that. However, obviously, there are two challenges there. So one is noise, and the other one's redundancy. And I'll go into that now. Noise. What does noise mean? Well, you saw the XML example. Maybe you've got a tag in there that says timestamp, or version, or some other form of temporary data that you really don't care about. Well, the system's going to report that as a change every time, which this is a noise that you don't want. But if you think about version control, in comparison to that, then this essentially means that we have a version control system, like think Git without the git ignore file, right? It reports all the log files, all the class files, all the artifacts that you really don't care about every time you say git status. So this is the noise I'm talking about. So if it's version control, we can get rid of that. I mean, that's a solved problem. We just need to apply that. And another way to think about that is if it's version control, then with the assert statement, you don't have the problem with the noise, right? Because with the assert statement, you kind of ignore all else that you're not checking. If you think about that, and if you think that we are controlling change, then this means the assert statement is a deny list of changes. So whenever I execute the test and this specific attribute that I care about, that I put the assertion on, has changed, then the test fails, so I get notified, and then I can still decide, oh, I'm gonna update the test. Like think about the initial example. I could change the login page such that it displays the username, right? And then this wouldn't be an error. But if I check for success, then I have to adapt the test. So I'm one by one controlling the attributes that I care about in terms of a deny list of changes. And if that changes, I have to apply the change manually to the test. If you now think about git ignore, it's an ignore list of changes, right? You specify, okay, these are the things I don't care about. Like there could be a date or I don't know, anything temporary, whatever, weather notification or anything, and you just say, okay, I don't care about that stuff. Right now I want to care about the login, which means that you have to specify something in order to ignore the changes you don't care about. And this is a spectrum, right? So on the one extreme, if you have no assertions, you ignore everything, so you check nothing. On the other extreme, if you have no git ignore, you check everything, right? This is the spectrum we're moving, and we want to be probably somewhere in the middle, right? We don't want to check everything, but we don't want to check nothing, so this is where we want to go to. Another question is, what's the better approach to get to that point where we want to get? And if you think about it, well, for Google, for example, they have, or I don't know if they still have, but they had the possibility to mark some UI component that has changed. So if you're a manual tester at Google and you see that unicorn, the dancing pony on the screen, this means that this UI component has been changed and you better test it thoroughly. So this is the idea behind it. However, at some point they forgot to remove the markers, which means that the customer suddenly had dancing ponies on their screen. Apparently nobody had a test coded for that. So what I want to say is, you can't create an assertion for something that you don't expect. If you never think about, there could be dancing ponies on the screen, you don't put an assertion for that, right? So you will never get notified about that. So if you go back to that, essentially think about creating a firewall and manually closing the ports, right? This is that approach, whereas closing all ports and just opening what you're fine with is the ignore list approach. And right now, we're doing that. So if anything happens, like with the umbrella, if anything happens that we didn't know or didn't expect, you won't know. Your test won't tell you, probably. And the other thing, which I think is important, is typically we want to care about more changes rather than less. So you don't want to code all of that in terms of assertions, right? You'd rather create an ignore file for that. Which is why we internally call this also Git for the GUI. So as I said, with git ignore, you have an ignore file. And with Recheck web, which is what I'm talking about, we created, or Recheck in general, which can be applied also to XML and other things. We created something similar, so you just globally specify the attributes that you don't care about. Like you can say, I don't care about the class attribute. I don't care, like you could use regex, I don't care about anything data. I don't care about link attribute, links, like any link that goes anywhere, I don't care about. You can specify via ID or XHTML, XPath or anything, and of course you can combine. You can say, okay, I wanna ignore the font for that specific UI element that I don't care about. So for us, an ignore is also a filter, so you can even apply that dynamically. And this is something that I want to show. Actually. So if you consider these two websites, as you can see, they are very, very different. So there's everything's different, the color, the font, the place, positioning of the elements, like everything. And now we want to compare that, and this is actually the commercial part of the product, but It's very visual, so that's very positive. So as you can see, we find all the differences. So we just say, okay, basically everything's different. But because we do it in a semantic way, we can now specify and ignore. So we can say, okay, I don't care about positioning. If the elements move around, whatever, ignore. I don't care about style attributes. Like if you have font, color, whatever, just ignore that. And you can say, I don't care about any invisible attributes. These are the filters that come predefined, but you can define your own. So I don't care about class, ID, whatever, XPath. And then you end up with just the changes in content. And I give this example because it shows an extreme. So it's very, very powerful. And if you can filter out all of these differences, you surely can filter out all of the differences on your own, whatever website that you don't care about, right? So this is kind of the message here. And most existing solutions that do Golden Master testing with websites are pixel-based. And like with a pixel-based approach, you just get, everything's changed. So go figure yourself. And we can do better. That's the demo. Just in case. Yeah. And what's also cool is that it works with animations. Like if you have animations like this, typical pixel-based approach would just as well tell you, everything's changed. But using our approach, we can tell you exactly that, for instance, this text changed and the animation now starts 2 seconds or 0.3 seconds later. So the second problem that you usually have with Golden Master testing is redundancy. So the thing is that if you have, say, 1,000 tests of your website and you change the logo, well, guess what? You now have 1,000 failing tests, which kind of, is a problem because you have this usually big overlap. If you go for the whole website, not for individual components, like you can do with Jest, if you know that tool, that's also Golden Master based, or they call it snapshot based, but it's essentially the same. So if you don't go for individual components, but for whole websites, then you have quite an overlap in terms of what you're checking. So if something changes, usually a couple of the tests that are related to that breaks. And we address that with our own CLI. So we have a CLI that you can install, and we create a report at the end of the test that you can use to apply the changes to the tests. And you just, with a CLI, you just say recheck commit, then you give it the report that you want to apply. And in that case, you say all, which means that you apply all the changes. But if you don't, if you want to apply a specific subset, you can again do so with filters. You can say, okay, I want to apply every change that matches this filter, and then apply, I don't know, ID changes or whatever. And you can do so also via the GUI. Now, hopefully you all remember the example where the test executed just fine, although the ID changed. So I'm going to explain how we did that. So usually in most Selenium tests, you have an identifying attribute. That could be ID, that could be XPath, name, text, class, whatever. So it doesn't really matter what it is. It works all the same. This is the ID. This is the attribute that you use to identify the element that you either want to interact with or that you want to check if you still use assertions, right? And if this single attribute changes, then the test can't find the element anymore, and your test breaks. Now, as you saw, if you use Recheck, that doesn't happen anymore. And at first, this looks like magic. Like, what happened? Why? I mean, it should fail now. Why didn't it? And but if you think about it, it's essentially pretty simple. Because what we did is we created a copy of the website. And guess what? In that copy of the website, the ID is still there. So what we do now is, if something changed, I always use the example of the ID, but it applies the same for text or anything. If that attribute changed, we can now simply go into the old version, the copy of the website that we have, and find the element within that copy. Then we can go to the live website and make a one-on-one assignment of all elements of the old version to the new version and find the element with the highest match. So you have, even if a couple of things change, like here it's ID and text and color. it's still the only button that changed. Like if you make the one-on-one assignment, it's still, I mean, it has to be that, right? I mean, there's nothing else that changed, so it has to be that, which means this is the best match. So we return it, in that case to Selenium, and just use the new element, and the test doesn't break. Of course, if you maintain the golden master, if you now apply the change to the golden master and remove the ID in the golden master, then your test breaks. So it's not completely unbreakable yet. But we lock that. For now, we tell you, okay, if you apply the change to the golden master, then you have to use this new piece of code with a new ID that's been changed, or you can use a retest ID. And I'm going to tell you in a minute what that is. And you have to update your this Selenium test. And because of reflection, we can even tell you which test in which method. And the next thing that we're going to do, we haven't implemented yet, but the next thing we can do with that, because we have all the information that we need, is we can update the Java code. So we can, now we have all we need to do that. So we can, if you want that, go there and say, okay, we're going to do that for you. And this essentially makes the test even more unbreakable, and it kind of realizes, I don't like the term, but codeless automation. I mean, everything that runs on a computer is, by definition, has to be code, because that's all the computer understands. So that term kind of makes no sense to me. But the idea behind is that you have low-effort test creation, because you just capture and replay, and you have low-effort test maintenance, because you don't need to touch the code. And this gives you that ability, because we don't need to specify assertions anymore when we record the test. We just execute it. We just, log in. We don't need to specify, this is what I want to check. So you just use the application and record it. And with that, we can automatically maintain the test, which, gives us the ability of codeless automation, if you want. But we haven't implemented that yet, so we're working on that yet. Still. Now about the retest ID. So what's the thing with the retest ID? Well, the idea behind that is, while we create the copy of the website, we can introduce additional attributes into that copy of the website. Attributes that don't live on the live website, that are only within the copy, which means that they never be affected by any change. Right? So however, unless you delete the element completely. But because the element, these attributes don't live on the actual website, they only live in the copy. So if you're a tester, you probably had the problem that your stupid developers keep on changing ideas all the time, and your tests keep on breaking, right? This is the solution to the problem, because now you don't care about the live website anymore as long as the element is still there. You can reference something that is virtual and constant. No change on the live website can affect the retest ID. And essentially it works the same. So if you want to use a retest ID, and that's a drop-in replacement for the find by mechanism, then we go to the golden master, find the element there, make a one-on-one assignment, return the best match, and return the element. We just this time do it with the retest ID, and this is, as I said, it's virtual because it doesn't exist on the actual website, and it's constant because it's virtual. And it also addresses other problems. Like, I don't know if you ever had that, but some people are annoyed by, if your element doesn't have an ID and has a complex XPath or whatever, and you can't really address it, well, guess what? Every element has a retest ID, so you just can go into the golden master, get the retest ID, and this problem goes away. You can now, and you can define it as you want. It's a string. Like, you can change it. If you want to change it, you can do so. So you can have it any way, any value you want. Right now, the support for that is not very good, unfortunately. So right now, the golden master for us is an XML file. So right now, you have to go into the actual XML file and find the retest ID, which is not nice. And then you can use it. But we're working on that, and we probably will fix it by letting you, say, replace the occurrences within my test with a retest ID. Like if I use an ID or an XPath or whatever, even without the test breaking, I can replace that, and it will give you that. Sorry. Another thing this realizes is data-independent tests. So we had one customer that was able to, they had the problem that they had changing test data. So like every other week, they would take like 10% of the production data into the test system and run all the tests manually, because you can't code a test for that, right? If you have a test user, John, and John, you know, deletes his contract, then the next time you execute the test, John is gone. So you can't execute the test anymore, right? So they didn't automate tests. But you can do so now in an abstract manner. So you can create a test that, say, clicks on the first customer, or on the first contract, or on the first item, whatever, and clicks through the application. And this gives you the possibility to create data-independent tests. You now have a test that you execute the first time, and you execute it to create the golden master. Then you have new data in your system, right? So you execute the test the first time, create the golden master, then you flip the code, then you have the new version of the code with the now old data. You re-execute and you see all the changes that are there only by the application. This is something that one of our customers realized, and this is now possible with that. So, to summarize, what Recheck gives you is a rule-based deterministic ignore mechanism. Like, I mean, there are other tools out there that, for instance, I don't know if you know Applitools, they use AI to find non-meaningful differences and filter that for you. So filter out the irrelevant changes for you. But then you need to you kind of depend on the AI to do that for you, right? And the AI has to learn, and it's kind of, you know, unpredictable in a way. And this is rule-based, so you can define your rules. And what I didn't show here is you can even have a JavaScript file. So if that doesn't suffice, if the gitignore file that we provide, or the mechanism that we provide doesn't suffice, you can define your own rules in JavaScript where you get the diff, and you can say, okay, I don't know, the diff is whatever, below 5 pixels, I don't care. Or you can say that's a part of the URL, like the base system and the test system. So that part of the URL I want to remove, whatever. So you can specify your own rules for that in JavaScript. As I said, it's open source. So you can fully use it. Right now it's implemented for Java, but and this works as I showed you, but we're looking into an implementation for JavaScript, which we hope will be ready in 4 to 8 weeks, and then we can have it for Cypress or for Puppeteer or for sorry, for frameworks like that as well. But right now it's just Java. You can use it offline because the golden master is just a normal file, so it's created locally. You can use, which I didn't show, you can use additional services if you want to upload it, you know, team functionality and all of that. But plain old, simple, it's just a local file that's created, so you haven't any external dependencies. As I showed you, it gives you unbreakable Selenium. Unbreakable, I mean, if you remove the element, the test will still break, but it's way more robust than it used to be. And in principle, it works for any technical interface. So what I showed was the web implementation, and we have a proof of concept implementation for XML that shows that it works the same for that. And in principle, you could use it for any technical interface as well, for JSON, for any format that you want to use. Like if you could have it between the database and snap the database communications, whatever. So that in principle it works for all of that with the same mechanisms of ignore. People generally like it, so that's the feedback we got so far. So you should try it. As I said, it's open source. It's on GitHub. It's Recheck Web. You can just go there and give us a GitHub star. And if you want to try it, sorry, you can take photos. If you want to try it without setting up a project, like if you don't have a Selenium project and you're still interested, you could use our Chrome extension and use the Chrome extension to create the golden master and create the comparison result and then load that into your browser. Load that with a GUI or with a CLI to find out the differences. So if you want to try this without having an actual Selenium project, or if you do manual testing, like we have customers that use this, they have a manual test process, and they have big websites with lots of data, like I showed you, and they need to find the very detailed differences. So you can do that. You can use that even for manual testing, and it will give you the differences of two websites. The business model, just so you know, we're making money out of that. We have a fully, as I said, it's fully open source. But however, we have Git and GitHub is our role model here. So the core thing is fully open source, and you can just use it. And we have additional services on top of that, where you can store, for instance, the golden masters and the reports. The GUI is proprietary if you want to use that to maintain the golden master. So for the apply, you can use a GUI. And what's even cooler, the reason why we started this in the first place is because we wanted to use AI for test creation. And the problem with AI is that if I have an application that says the result is 5, then the AI doesn't know whether that's actually correct or not. So if you create a test with AI, the AI can't say, oh, this seems to be wrong or this seems to be correct. That's right now just not possible. So what we do instead is we have the AI create all of those tests and just show the differences. Like the AI execute, you can think about it like a complex crawler. If you have a web application, the AI will kind of crawl your website or web application and find all the paths through the application. And if anything changes, it will show you the changes, like with what I showed you. And you can have two different kinds of AI for that, because if you know about artificial, AI kind of is a hype right now, and artificial neural networks, they usually require a lot of training and training data, and most people don't have that. Like if you have a small website with just a website, then you don't have thousands of test cases to train the neural network on, right? So we provide a pre-trained neural network. However, that's not trained specifically for your own website. That's trained, what we learned out of that is that's essentially trained how a typical user uses a typical website, which means that it learned UI, UX design principles. So it's learned that a bigger button is more likely to be clicked, or elements that are close to one another are more likely to be used together. So this is essentially what the artificial neural network learned. And you can use the genetic algorithm on top of that and give it some examples. Like if you have, like I showed, if you have a login, then you can just record the login, which hopefully is difficult to guess for the neural network. So you can give it a recorded login example, and it will use that to generate tests based on that login. So it will, if you give it bits and pieces, it will use that to learn and create the internal model of the application and go from there. So essentially, you need to give it everything that's not intuitive. Anything that, if you have a new user or a new tester, you would have to explain it to him and say, we use typically that context for testing. That's what you give to the AI, to the genetic algorithm. So, yeah, that's the talk. Any questions? Yes, please.
I have a lot of Selenium tests today. What's the easiest way to sort of switch to this? Is just remove all the asserts and run it? Or?
I can essentially show you. So the question was, for those who didn't hear, what's the easiest way to switch an existing Selenium test? So I'll just redo that. So it just let me make sure. Delete. So if you want to switch your existing test to that, you just say new recheck driver, and you remove the assert. And now the first time you execute your test, it will fail because there's nothing it can compare against. Like there's no golden master yet. It has to create the golden master. The first time it will fail. So now it says No golden master found. Can you read that? That's a bit small. It says no golden master found. First time test was executed, and this needs to be that way. Like if you forget to commit your golden master, or if the path changes, then it would always be green, and you don't want that. So if it doesn't find the golden master, it has to fail. And the first time there's no golden master. And now if I change the ID, now it already works. Hopefully. Yeah, so as you see, that's kind of it. All you have to do, you have to add the dependency, you have to configure the project, everything like that. But after the initial setup, all you need to do for your existing Selenium tests is essentially wrap your driver in the Recheck driver. That's kind of it.
Where's the golden image?
You can define that. So the way it's defined now, because this is sorry, to repeat the question, where is the golden master stored locally? So this is, as I said, it's a file. It's an XML file, and what it does is, this is with the Recheck driver, it implicitly creates a golden master every time the driver interacts with the website. So after the send keys, after the get, after the send keys, and after the click, a golden master is created, and it's stored here because it's a Maven project, so it's under source test resources, but you can figure that. You can, if you have a different project layout, whatever, you can configure where it should store the golden master. And if you don't want to have a golden master after, this is using, as I said, the implicit mechanism, you can do so explicitly. You can say, instead of creating a check or a golden master every time, you can instead use the recheck impl, or just the recheck, and say, okay, I do whatever, 5 interactions, and then I want to check. And then I do 10 interactions, and then I want to check. Like if that's more, if you want to reduce the amount of golden masters, you can do that by explicitly using a recheck. Any other questions? Okay, if there are no other questions, then we're already done. As I said, my goal today was that you get interested enough that you give us a GitHub star. So if you do so, you can come and get a sticker. Still bribing. And I hope you liked it. If you have any questions, even after, if you try this in 4 weeks and have questions, please don't hesitate to contact us. So this is all still pretty fresh. So this is like 8 weeks. We started this almost a year ago. But the thing that you just saw is not very old. So there might be still problems with the documentation. Maybe bugs, something. So if you find anything that doesn't work as you would have assumed, please get back to us and we'll try to fix that. So this is very fresh and very new. So yeah, be patient with us and we'll fix it if it doesn't work for you. If there's no more questions, thank you very much.